Hey, today we are, everyone's eyes and ears right here, please. Today we're doing A4 using corresponding triangles and proofs. So we get to use this cool thing called CPCTC. Okay, you should have just read about that on page 426. CPCTC stands for
Corresponding parts of congruent triangles are congruent.
good corresponding parts of congruent triangles are congruent. In other words, if you can prove that two triangles are congruent, then you can prove that their corresponding parts are congruent. Now, throughout this chapter, I've made a big deal about you having different things in the correct order, and that's to prepare you for what we're doing in 8.4. Okay, so that when you say triangle ABC is congruent to XYZ, then we automatically know A is congruent to X, B is congruent to Y, and angle Z is C is congruent to angle Z, because we put them in that order. So when we're dealing with corresponding parts of congruent triangles congruent, we don't want to write that out every time, so we use the abbreviation CPCTC. All right, so on page 426, you kind of read through the think and discuss. You have question number 1 there. Suppose you know that triangle ABCD is congruent to triangle ADB by side angle side. Which additional pair of sides and angles are congruent by CPCTC? All right, what'd you get, Haley?
A and C would be congruent.
Okay, we're looking for a pair of sides, so A.
Oh, sides. Oh, well, that'd be A and D and C and D.
Okay, so A and D and C, B. Okay, good. So A corresponds to angle C, so A to D would go C to B. All right, and then you had your angles. What angles did you say?
Oh, A and C, and then would there also be, yeah, D and B too?
Yep. Good. So we could say angle A is angle to C. We have to say angle ADB, right? Because angle D could represent this angle. So, or we could just call it angle 3 and angle 2. That'd be fine. What's that? Questions there? So that's using CPCTC. So if you're doing your statements and reasons, this would be your statement. Your reason would be CPCTC, because you already proved the triangle's congruent. So if you said these triangles congruent, then you can automatically go to sides, or angles are congruent. What other conclusions can you make about the segments? What else can we say, Chase?
DD is congruent to BD.
Okay. DB is congruent to BD by reflexive. Okay, also CPCTC, I guess. Any others? No others. What do we know about this line and this line? They're parallel. How do we know they're parallel? Tell your neighbor how you know they're parallel. Focus in right there. Good. Alternate interior angles. Prove triangles congruent. Or prove the lines parallel.
Bring those back.
Yeah, we'll keep bringing those back.
Oh, great.
Okay. Very good. Any questions? I want to get you guys going into your other piece, but let's look at number 2 just real quick. There's example 1. You look through the proof, hopefully. All right. You can show that angle A is congruent to E if you can show that these angles are corresponding parts of these triangles. And then use CPCTC. So they've kind of walked you through that on this proof. State 2 relationships that are true about AB and ED. So this and this. What are two relationships we can say that are true? What's one?
Which one would be that they're like parallel or no?
Are they parallel?
Never mind.
Don't give up that easy. Well, first, if this triangle is congruent to this triangle, if ABC is congruent to EDC, what's one relationship we know? Yeah. Well, we definitely know that they're. So you're jumping to this being congruent to that. Okay. So we know angle A is congruent to angle E. We've said that here by CPCTC. So if this is congruent to that, based on alternate interior angles, we know that those two are parallel. So you were right. Yeah. You just let me talk you out of it. Okay.
Good job, Haley.
What else? Chase?
Would angle ACB be congruent to angle ECB?
Yep, we've got that. Vertical angles, that's in here.
Oh, wait, sorry. Oh, I meant ACB congruent to BCE.
Yep, right here and here.
Yes.
Yeah. What do we know about AB and ED? Grace? Oh, is that?
I was going to say that aren't they congruent?
They are congruent, yeah. Based on CPCTC, we know that AB is congruent to ED. Is that what you're going to say?
Yes.
Yep. Okay. Both on this one's CPCTC and this one's alternate interior angles. Oops, interior. And this one's CPCTC. All right. All right. What I want you guys to do, I want you to take a look at your activity. So you have that hopefully in front of you. Okay. Take a look at that. If you didn't grab it on the way in, make sure you grab one. This guy right here. I want you to fill in the blanks, statements and reasons, to finish that 2-column proof on the top there. In fact, that one, why don't I kind of have you guys, why don't I give you 2 minutes to get as much as you can filled in, okay? Then we'll kind of walk through it, and then you'll do the activity on your own. Go for it.
AB is parallel to BC.
All right, if you haven't shared it with your neighbors yet, go ahead and do so now.
Because alternate.
Oh yeah.
Oh yeah. I like to fill in the blanks a lot better, like easier.
Okay, let's see how we did. Statement 1, what do we have?
AB DC. That's given.
Okay, AB parallel to DC, and that's given. Statement 2, Grace.
Angle B is congruent to angle B because of given.
Okay, given. So I didn't go through and say, we're trying to prove BC congruent to DA. So this side right here, congruent to that side there. So if we could prove ABC congruent to CDA, that would help out. Okay? All right, so we have parallel, we have congruent. Those are both given. What else do we have? Someone new. I think yes, Cameron. AC congruent to CA. How come? Okay, reflexive there. Now, I've seen some pretty interesting abbreviations on quizzes. Unless you see me write the abbreviation, you cannot use it.
Oh.
Okay? Like we've seen, I saw some amazingly creative abbreviations. So it has to be a common math abbreviation.
Can I just write reflex instead of reflexive?
You could write reflexive.
I just thought
Yeah.
Flex it here.
I would be fine with reflex. Huh?
It needs to be a P, not a B, because
Prop.
poverty.
Yeah, not prob. You're right.
Bro,
Thank you.
I've seen some pretty
Bethany.
crazy abbreviations too.
Angle BAC is congruent to angle CACD by alternate interior.
Okay, so we have angle BAC DCA. Okay. I don't know if that's the order you said them in.
I said ACD,
Okay, so BAC and DCA. And that's alternate interior?
Congruent, I'm thinking right.
All right. They're congruent. So we've got that one and that one.
Could you also write that the AD and BC are parallel to each other? Because alternate interior.
We don't have that yet. We'd have to have a transversal there. We don't have a transversal. Okay, do we have a triangle congruent yet? What do we have, Carson?
Angle AB or triangle ABC congruent to triangle CBA by angle BC.
So ABC to CDA by angle side? Is that what you had? Okay. Very good. And then BC congruent to or DA, excuse me, by CP. Unbelievable.
CTC.
Having a problem with my B's and P's today. CPCTC.
How did you say it fast?
All right. Hey, Tim.
CPCTC.
Okay, ladies and gentlemen, go. Oh, hold on. Hey, you got a second?
CPCTC.
Okay, Emily.
When you're like stating the triangles congruent, you can say it in any order as long as they're corresponding parts.
As long as they're corresponding parts, unless it asks you to state a specific triangle congruent. Hey, guys, you're talking over there. I'm talking. Okay, unless it's asked for a specific order in the proof statement, then it doesn't matter. Okay, as long as they're corresponding parts. Okay, give the activity a go. There we go. Next piece. So, what do we have right here? Number one. Chase.
Do you do both of the givens there?
We're going to do one of the givens there.
Okay, so line QK is congruent to line QA.
Okay. And number two, Diamond.
Would it be
Definition
definition of
of
Bisect.
bisector. Well, okay.
That's what I got.
Definition of angle bisector. So if that's the case, can this be that?
Oh no, okay.
Yeah, so if we use definition of angle bisector there, we actually have to say that this was a bisector first. So that would actually have to be our first statement. QB bisects KQA. All right. So we have to state that before the definition of bisector. Now, Zach? QB is congruent to, let's go QB because it'll fold on top of itself. So this corresponds to that and that corresponds to that. Okay, triangle KBQ. So if we have that to itself and we have, which one do we say? Q, so that guy there to that one. Emma? Side angle side. All right, and the last one? Rory? Good, CP, CT, C. All right. Any questions there? Okay, let's go ahead and take a look at our assignment then. All right, so where did I put those? Okay, so 1 and 2 you've got proofs for on the example side. 3 and 4 you're just doing the reasons for each statement. So you don't have to write a full proof on 3 and 4. Okay, just reasons for A and B. Okay, 5 and 6, a proof, and 7 a proof. So you have 1, 2, 3, 4, 5 proofs. Then turn it over. Okay, so on the back here, you need to do 1, 4, 7, and 10. 1, 4, 7, 10. Okay? Yes?
So on the ones on the back, are we proving what's written right there? So
Yes. Yeah, you're proving angle A congruent to angle C. This angle congruent to that one, and then right here. Okay? Notice your givens on these 3 are just in the picture. So if they're marked in the picture, that's their given. Okay? Questions? Just so you know, you're able to knock off, by your participation today, you're able to knock off 4 proofs. Okay?
Could
That's a
we
good
have
one.
had knocked off more?
Nope.
Oh, okay.
That's the most you could have knocked off there. Yeah. All right. Very good. Make sure you're asking questions. Okay?
2